Hello students, welcome back to Organic Chemworks YouTube channel. In this series of videos, I am going to solve some of the interesting and important questions for the competitive exams like JEE and NEET. In this video, I am going to solve a question based on the isomerism and halogenation of hydrocarbons. Let me read the question. If X is the number of different compounds produced on monochlorination of cis-1, 2-dimethyl cyclopentane, then find X divided by 2 value. We need to include the stereoisomers as well. First, let's write down the structure of cis-1, 2-dimethyl cyclopentane. So you can see here both the methyl groups are above the plane, right? That means they are cis to each other and they are at first and second position. Therefore, this is cis-1, 2-dimethyl cyclopentane. Now, this upon chlorination, monochlorination, that means what? You have to replace one hydrogen by one chlorine, right? Then, how many products we can expect, right? So, that is X value, including stereoisomers, and then we have to divide that X by 2. This is a hint that X value here is a even value. Say after writing all the molecules, right, if you would have got X as an odd number, it's just a hint for you to check again and verify what is the actual number of stereoisomers possible. Okay, so let's start writing the structures for monochlorination of the cis-1, 2-dimethyl cyclopentane. What I'm going to do is I'm going to replace the hydrogens on different carbons. Say there is one hydrogen here, I can replace this to form a different product. Same here also, same here also. But if I replace here, that will be same as this. If I replace here, that will be same as this. And of course, we can replace the hydrogen here also from the methyl carbon also. Okay. So let's start writing the chlorine. Say the chlorine is here. Okay. Since the reaction is taking place through free radical mechanism, all right, what happens? Since it's a reactive center, the chlorine can come above the plane also, like this. It can be above the plane also. What about our methyl? Methyl is still below the plane here. Okay. So now we have removed this particular hydrogen to get two different products. Look at this, the methyl group here, they are on the same side. What is it then? Cis. The methyl group are opposite to each other. Then what is it? They are trans. Cis and trans. What is the relationship between these two molecules? They are geometrical isomers. And look at these two, they are chiral carbons. And when you compare the molecule, they are non-superimposable, non-mirror images. What is the relation between non-superimposable, non-mirror images? They are diastereomers. What exactly that means? Suppose if you give R and S configuration for these two carbons, okay, let's assume that you are getting the configuration as S and R. And when you do configuration for these two carbon, you are going to get S and S. And what is the relation between SR and SS? It is diastereomers. That means not just geometrical, it is exhibiting the optical isomerism also. That means what? Due to the stereoisomerism, the two diastereomers. Let me write that also. Diastereomerism, due to that we are going to get two more molecules. So all put together there are 4. Alright. Now let's move on to the next carbon. Okay. Look at this. I am going to keep these two methyl as it is fixed here because the reaction center is not here. So no matter what, it's going to be the same. Okay. But what about the chlorine here? The chlorine can be above the plane or chlorine can be below the plane, like this, right? Now again, all these are on the same side, so cis. These two are cis, but it is trans to this, cis sign trans. So how many isomers possible here? Two geometrical isomers. What about the diastereomerism? In order to do that, just check if they are mirror images. No. Are they superimposable? No. That means what? Say suppose if this is SRR, say let's assume so, then this will become SRS. So what is the relation between SRR, SRS? That is a diastereomer. Therefore, we are going to get two diastereomers also, because in the question it says all, including all stereoisomers. So diastereomers would be 2. How many we got here? 4. Now moving on to this carbon. Okay, so now I'm going to first fix the positions of the methyl because it's not going to be changed. Alright, now the chlorine. Chlorine can go above the plane or below the plane. There is no control because it's a free radical mechanism, as I told earlier. Now all the groups are on the same side, so it is cis. What about here? The other molecule is trans molecule. And how many we got here? We got 2. Now although we have chiral carbons here, right, due to plane of symmetry, we don't write any diastereomers. Okay, so let me repeat this carbon, right, although it looks like chiral, but it is attached to the same groups on both the sides and it has plane of symmetry. So I'm not going to write diastereomers, only cis sign trans is possible. Now the last one, we have to remove hydrogen from here, right? So when you remove that, look at this. This will remain cis only because the reaction is not happening here. It is happening over here. So the chlorine is here like this. Okay. Students, remember, although these two hydrogen looks like they are symmetrical or they are identical, okay, but they are not, because when I remove hydrogen from here, right, I'm going to get a molecule like this. And look at these two molecules. What are they? They are mirror images. If I draw a mirror here, right, it looks like they are mirror images. Are they superimposable? No, they are non-superimposable mirror images. So they are enantiomers. Enantiomers. What I meant is, if this is S and R, we are going to get it as R and S. Okay, let me repeat the last part. Although we assume that methyl are same, they are identical, if we remove we are going to get same product, because here that's what I told, but in this case it will not happen like that because it's going to form a non-superimposable mirror image. That means they are enantiomers. So now let's add all the values. We got 4 here, 4 here, 2 here and 2 here. 4 plus 4, 8, 10, 12. All put together we got 12. But the question says that x by 2. So x by 2 is equal to 12 by 2. That means what? 6. The final answer is 6. So the final value for the given question, it is 6. I hope you have understood this, and if you still have any doubts, you can always post your questions in the comment section, or you can always write to my email ID. Thank you for watching this video. Until next time.